In this video, we will learn about non-flow work in various quasi-static process and learn about work done in constant volume process, constant pressure process, adiabatic process, isothermal process, and polytropic process. So first, let's start our topic. First is constant volume process. Constant volume process and constant volume process, since volume is also called isochoric and isometric process, and since we know that W is equals to integral of P dV. If we draw graph, this will be PV 1 2, this will be constant, so 1 2. Now since constant volume process, dV will be equals to 0, so work done will be 0. So work done will be 0 for constant volume process. Now this is the first and the second constant pressure process, constant pressure process. So if I draw, this will be the pressure, this will be volume, so an area under this will represent the work done. Now W is equals to 1 to 2 P dV. Since pressure is equals to constant, this will be taken out, 1 to 2 dV, and we are equating from V1 to V2, then we are getting P into V2 minus V1. So this is called constant pressure process. Now we will learn about isothermal process. Isothermal process. Now isothermal process is a process in which temperature is equal to constant. So if we drawing for ideal gas, PV is equals to mRT. So here temperature will be constant, temp will be constant, R will be constant. So what we are getting, PV is equals to constant. PV is equals to constant. Now for if we are going from 1 to 2, so we can write, if PV is equals to constant, then P1 V1 is equals to P2 V2 is equals to P into V is equals to constant. Now if we know that now we have arrived the condition that P1 V1 is equals to P2 V2 is equals to PV. Now work done will be P into dV. So we are writing a P into V. From here we are getting, from this equation, V will be V will be P1 V1 upon V. P will be P1 V1 upon V. We are putting in this equation. W is equals to integral of P1 V1 divided by V into dV. Again solving this, we are getting P1 V1 1 to 2 we are basically solving. So P1 V1 ln V2 divided by V1. Now again, since P1 V1 is equals to P2 V2 is equals to constant, so we can write P1 upon P2 is equals to V1 upon V2. So by this first equation become W will be what? P1 V1 is equals to ln P1 by P2. This is the second equation. This is the first equation. This is the second equation. And now we know that PV is equals to mRT. So in case of PV, we can write W is equals to mRT ln P1 by P2 or MRT ln V1 by V2. This equation will be also valid, these two equation. Sorry, V2 by V1, I am very sorry. Now this is for isothermal process. Now we talk about adiabatic process. Adiabatic process. Now in adiabatic process, likewise we are studying about isothermal equation that PV is equal to constant. In adiabatic process, generally PV to the power gamma is equals to constant, where gamma is equals to Cp by Cv, that is ratio of specific heat at constant pressure to ratio of specific heat specific heat at constant volume. So by this we can write P1 V1 to the power gamma is equals to P2 V2 to the power gamma is equals to P into V to the power gamma, P into V to the power gamma. So work done will be integration of 1 to 2 P dV. Now we are substituting value of P here. We will be getting P1 V1 upon V to the power gamma is equals to P. Putting this value in this equation, we are getting 1 to 2. Sorry, here gamma will be gamma upon V to the power gamma into dV. Now we have arrived to this situation. Now what will happen if integrating in from 1 to 2, we get W. We are getting P1 V1 to the power gamma, P1 V1 to the power gamma is equals to this will be V1, this will be V1 minus gamma plus 1 upon minus gamma plus 1 from 1 to 2. W will be P1 V1 to the power gamma. We will be getting V2 to the power minus gamma plus 1 minus V1 to the power minus gamma plus 1 upon minus gamma plus 1. So W will be, if we are multiplying, since this is P1 V1 to the power gamma, we can write P2 V2 to the power gamma for this V2, and for here we can write P1 V1 to the power gamma. So P2 V2 to the power gamma, V2 minus gamma plus 1 minus P1 V1 to the power gamma and V1 minus gamma plus 1 upon minus gamma plus 1. So W will be, if we are solving this, we are getting P2 V2 minus P1 V1 upon minus gamma plus 1. So W will be P1 V1 minus P2 V2 upon 1 minus gamma minus 1. So this is for adiabatic process. This is for adiabatic process. This is work done for adiabatic process. And if I say about polytropic process is nothing but the equation governing for polytropic process is PV to the power n is equals to constant. PV to the power n is equals to constant, and here n varies from n in general, in theoretical n varies from minus infinite to infinite, but for our general use, for our on the basis of devices that we use, the n varies from 1 to gamma. Gamma is ratio of Cp by Cv. Now this is for this polytropic process equation governing for PV to the power n is equals to constant. It is similar like adiabatic process. So if we carry out the whole process, we are getting work done in polytropic process. Work done in polytropic process, we are getting P1 V1 minus P2 V2 upon n minus 1. N minus 1. This is polytropic process. This is for polytropic process, and we are concluding here. We have studied about constant volume process, that is work done will come to 0, and for constant pressure process, work comes to be P into V2 minus V1. For isothermal process, these are the work P1 V1 alone V2 by V1. If you can remember only one, then all can be easily typed. And for adiabatic process, we have learned work done is equals to P1 V1 minus P2 V2 upon gamma minus 1. And for polytropic process is a process in which the governing equation for polytropic process for ideal gas is P into V to the power n is equals to constant. Please remember this, because certain confusion may be arrived. The governing equation is P V to the power n is equals to constant, where n varies from, in theoretical, n varies from minus infinite to infinite, but on the basis of our devices that we used in nowadays, so n varies from 1 to gamma. Gamma is nothing but Cp by Zv, and if we perform the same process as we done for adiabatic process, the work done for polytropic process come to be P1 V1 minus P2 V2 upon n minus 1. Okay, thank you.